We'll start with a little history of how we came, how innovation impacts growth and change of companies. So just at my particular company, we've been around for well over 100 years. We started with an acetylene torch and changed our product and innovated new processes and products until now we're one of the largest manufacturers of robotics. And it grew out of the need in the automotive industry basically to have automated welding. That's what led to the development of robotics eventually. So we've been constantly changing and innovating over 100 plus years to meet the needs of the market. And with CodeSys, I'm going to use a real world example of how we came into CodeSys, how it helped us evolve, what innovations it's brought. And basically in the past, as you see, everything was hard automated. So it was limited to a particular task or a particular industry. And then when we moved to CodeSys, it allowed us to address every industry. In the past, everything was all hard PLCs, hard automation, and everything was tied specifically to an industry, and you really didn't have flexibility. Having a global market and global industries, using CodeSys, it allowed us to enter many different industries that we weren't necessarily in before. You know, whether it's something as in, you know, building and metal products, automotive, medical, and even now these days in entertainment. It allows complete flexibility of entering any different type of industry. So what I want to do is talk about, we're basically releasing the KRC5, which is our 5th generation of controller. And then we started with CodeSys on our KRC1. That's when I joined KUKA, and it was a PC-based controller for our robots, so that provided a good fit into, you know, the CodeSys soft PLC application. Till that point, everything was hard PLCs. And with my background, I thought I joined the industry basically when the PLC5 was around. And it's like, wow, this does everything. It's small, it's compact. I can do 32 points of I/O in a single card. Wow, I won't ever need anything else. This is great. Because I touched a, you know, PLC2 or PLC3. They're big, bulky. And then I even had the pleasure of seeing a PLC1, which many people hadn't, and that was 8 points of I/O on a huge card. So basically the PLC5 hard PLC, for reference, was smaller. It was 4 times smaller, and it was 4 times greater in I/O density. So it's like, why do we even need to do anything? I won't need anything bigger or smaller than this. Then we came to an automotive customer that wanted to control a line with just the robot controllers. And that's what led us to CodeSys. We had a huge automotive customer, and they had a stamping line that had, I forget, maybe 5 to 10 robots on it, and they wanted it to be controlled all with the robots. That's when we moved into CodeSys. It allowed the robot controller to communicate to external devices and everything and have control independent of the robot, but have the coordination and supervisory control of the entire line all within the robot. And CodeSys allowed us to do that without having to add extra hardware to each robot controller. So there was no PLC added, nothing hard. All we had was the PC basically of the robot controllers, and it was controlling the entire line. So that's what led us to go into CodeSys to allow us to grow, because up to that point, everything was 100% hard automation. And through the innovation of the soft PLC, it allowed us to do line control without using external hardware. And that's basically how we became involved with CodeSys. Up to that point, to be honest, I didn't know anything about CodeSys. And once we got involved, I was like, wow, my power and flexibility. And as the power of PCs increased, so did the power of CodeSys. So that's where we are over the years, and it's just grown as, processing speeds and technology has grown. It's just made the product stronger, able to do more and more tasks. With that being said, I'd like to turn the presentation over to Konstantin, where he can show you how CodeSys integrates into the robot controller with an actual example.
All right, Mike, thank you very much. I will show you how we do right now with the KRC4 and KRC5, because the current robot controller that we distribute is KRC4 and KRC5, the newest one. So this where we are right now, and we said that we are using, nowadays the KRC4 and KRC5 controllers, and right now the interface between the CodeSys system and the robot system, we use field buses, Ethernet IP or Profinet, and because the field buses are right now the standard into the manufacturing. So this is just an example of a kind of classic robotic cell. It's just the palletizing. Some robots that are in the line, they are doing palletizing. But the line, it's always large. You're going to have many devices, conveyors, shrink wrappers, sensors, other devices, maybe cameras, and other things, weight checkers. And so all this large automation line is usually managed by a PLC, in our case, by the CodeSys. The CodeSys it has its own programming language and its own very good system for backups and updates. And however, the robots, they have their own controller and they have their own language. And from the maintenance standpoint for the plant, they're going to have to, let's say, manage two different systems, because the robot controller has everything it needs to run by itself. But as you see, it never happens, a robot to be by itself in a production line. So many customers say, oh, I need to learn two programming languages. I have to have two systems to manage for backups, for updates. There is any other, let's say, way to put everything together. So the system, as you see it right now, it works, it will work, it's functional, but it has a little bit of more work from the logistics and the maintenance to updates and backups and maintenance for the software maintenance. So that's why we said, let's think at a way to, put everything together. So sometimes, project requirements, they want a single platform, a unique programming language, and then unique backup system. So the solution, I think we said that to keep the CodeSys platform, because it's managing most of the line. The majority is managed by CodeSys, by the PLC anyway. So we created a library on the robot. We call it MX Automation, it's just a name. And that this library is able to receive the PLC commands and translate it into the robot commands, robot motion commands, robot signal reading writing commands. So the benefit would be that all application program or application layer will be created into the CodeSys language, and will reside into the CodeSys program. So on the robot controller, we're going to have kind of a background task that is reading and commands that are coming from the CodeSys application layer. So the big benefit is that if you want to update something into the line, you have a new product, or something you want, just for the pure maintenance of the line, you just change one program. That means the CodeSys change will be through CodeSys application program. So how we did it? So we have a library, a software library that is on the robot controller that is able to read the commands from the CodeSys code. So we have created a library on the CodeSys that is providing the function blocks specific to the KUKA controller. So we are able to issue motion commands, signal commands, interface commands, acceleration, deceleration, whatever the KUKA native language is able to provide for robot programming, we implemented into the MX automation library into the CodeSys. So like this, you have the opportunity, using the CodeSys library to program the KUKA robot from the CodeSys application. So we have multiple libraries for the CodeSys. For this MX automation option, you need to have, let's say, two components. That means the background task on the KUKA robot that is reading the CodeSys commands, and the CodeSys library, that is this one, that you have to upload, use on the CodeSys project. So this CodeSys library can, you use it, take it from the CodeSys store or from KUKA. And after that, to set up the system, you need to decide how you want to interface between the PLC, CodeSys, and the robot. EtherCAD, Profinet, Ethernet IP. So we have libraries for different communication types. So in my particular case, it's very popular Ethernet IP. So I say, why not? Most of the customers, they want Ethernet IP. But the other two will work in exactly the same way. So after that, we have, the CodeSys library. It's coming with a very comprehensive manual documentation that is in multiple languages, is German, English, French, and Chinese. And let's say this option, MX automation option, we created a while ago, a couple of years ago. So we have multiple versions that are matching the operating systems of the robots. So right now we have the version MX automation 303. This is a screenshot from the robot Panda. And this is what you need on the PLC side, on the CodeSys side. So if we put all these things together and we choose the communication style, well, we will be able to communicate. So this is the CodeSys automation, MX automation library on CodeSys. We have different libraries for different operating systems, and the latest is 311. And right now, I just want to show you how, let's say, how we communicate, how the communication is going through. So for my little example here, I just use Ethernet IP into the CodeSys. And this is a visualization on the CodeSys side. And this is the screenshot from the KUKA Panda. So I've used the Ethernet IP I/O driver. So the communication between the robot and the soft PLC, it's done through two. It's a binary communication, a very large number of I/Os. And by the way, the robot has 4,096 I/Os. And if you need the other 2,048, they are available for other things. And I see the communication, it is enabled, Ethernet IP on the PLC, on the soft PLC side, on the CodeSys, and the KUKA driver Ethernet IP is communicating. After that, this interface is, showing the correspondence between different indications on the robot pendant, because the robot, you need to know a little bit about the robot and robotics, how a robot works in general. You can't say that I'm using this CodeSys option library, MX Automation, and I will be able to program the robot in no time. It is easy, but you need to know the basics, how a robot works, how the coordinates are, what it means, and where is, the Cartesian transformations. But it's very easy to understand. So in this example, if you would use the robot pendant, you're going to have to look at all these indicators. The drives, if the robot is running, the robot is in manual or in external mode, in automatic mode, and this is the speed. That means it's running at 5%, very slow. And here are, for example, we see it's using the tool number 1, base number 1. It's extremely important for the coordinate system. So, as I say, we want to use the PLC CodeSys interface and have all the application layer on the CodeSys. So all this important informations from the robot pendant, we transfer it to the CodeSys interface. For example, the tool number 1, base number 1, same thing. And let's say we call it override, kind of overall velocity. Whatever we set on the indicator on the CodeSys will be going to the robot. And these indicators are just transferred into this CodeSys. And here I have some push buttons that will, let's say, connect to some function blocks into CodeSys that will transfer information through these 2048 I/Os to the robot. So instead of using the robot pendant commands, we can do everything from the CodeSys interface. So what we can do? Well, we can do basically the same thing that we would be able to do on the robot side. We can jog the robot. That means move the robot left, right, whatever, and we can teach points, record points. We can use different motion profiles. That means linear motion, point-to-point, circular motion. And, we need to know where the robot is going. So the coordinates, we can display the coordinates, I mean the robot's real position live in joint position, that means the angles, or the Cartesian position. So basically, all this wealth of information, very necessary, that are on pendant, everything is transferred to the CodeSys interface. So we can say we don't need the robot pendant, because as you see here, there is just a background task that is reading all the commands that are coming from the CodeSys application program through these 2048 IOs. So on the robot side, there is no application program. All these motion commands, everything will be stored into the CodeSys program. So I want to show you a little bit more here. For example, we said that we have many function blocks that are mirroring the robot functions. For example, here we have a function block that it says read axis position, read where the robot is, actual position. And different other commands, that means which axis we want to use for the robot to move. So all this, there are like many functions like that, because there are many robot commands. To be able to program a robot, there are many. So we mirrored and created the CodeSys blocks that you can use the same thing on the PLC side. So these are coming from that library that you saw previously. And here into the program, application program, is just a function call. So as you see, there are many. So it depends how you want to program the robot. First, we have blocks for initialization, for the motion commands. After that, we need to start. Then the robots in general, the KUKA and other brands, they need to enable different things. That means put power to the servo drives and have the robot in the running status to be able to issue motion commands. And there are input parameters that need to be set in the way that the robot is expecting it. So all this is done through these function blocks with these input parameters. And all is going through, the Ethernet IP IO communication. So for example, if we want to jog the robot, jog means moving the robot. If I would push on the robot pendant with the fingers, we have commands that we use on the CodeSys that will move the axis one by one, if you want to do that. So I have here a function block that is called KRC jog. So if we set different values on axis 1, 2, positive or negative, the robot will move like, positive or negative side. So this is a very interesting, busy slide, but it shows exactly the power of this communication and what we can do with CodeSys programming. So because everything is being transferred from the PLC to the robot. For example, first, we need to start. All this system need to be started. And I have here an auto start button that is corresponding with the start button on the robot pendant. It has the same effect if I would push on this button on the pendant or using this function on the CodeSys. After that, we can, reset messages. If there are leftover messages, would be this button on the pendant. And after that, we can display the robot coordinates that here on the robot teach pendant, I just took a screenshot randomly. So the robot pendant is showing these values for the XYZ. And if we look, XYZ here on the CodeSys interface, it's exactly the same thing. So this, it has quite some logic behind, because this coordinates will show the same thing only if these Cartesian systems are identical. tool one, base one, tool one, base one. And what else? It is here into the CodeSys variables, because this, what we show here on the screen, they are just some local variables on the CodeSys. And right here, I just display this variable KUKA E6 position, this is an array, that is stored into the global variables here, global variables into the CodeSys. So these values are coming through Ethernet IP to the between robot and the controller, or between the robot and the CodeSys. And as you see, I show you like many function blocks. And here I want to show that we have manuals in multiple languages that are describing, detailing all these function blocks of the library. That means reading output on the robot system. So this is a CodeSys function block that will allow you to do that. And there are many more. This is just the front page of the documentation. And here inside the manual, this is how it is. That means we describe every single block with the inputs and the outputs. That means what we need to enter and what will happen here, and the description of every single one. And this, we have it in multiple languages, these manuals. So as you see, there are like many. They're reading different things from the robot, writing to the robot. And so that's why we have, let's say, we can do the same thing from the robot. What you can do from the robot, you will be able to do it from the PLC, from the CodeSys. And the advantage is that everything is in one spot, on the CodeSys application program. If you use, of course, you're going to be using CodeSys to run the complete line. You have, let's say, a function block and some functions dedicated to the robot. So the advantage is that everything is in only one system and it's only one language. So basically, this was, how we use this library, CodeSys system to run a KUKA robot. And I just want to show you a live example. That means what I have here with an office PC, we call it. That means it's a desktop that is simulating a robot controller. It's kind of a robot, just a controller without the robot. So I need to share another screen. Let's say, let's stop this one. And I'm going to share the screen. And I need to find out how. All right. Share screen. All right. This is basically the same project that I'm running. I'm running CodeSys. This is my Raspberry Pi. And
we don't see your screen in the moment.
You don't see share screen.
You have to choose the screen and then push the button share.
Oh.
2 buttons, sorry.
Let's see. Share screen. Share screen is number 2. Aha. I share here. You see it?
Yes, perfect.
All right. Okay. So the target for the CodeSys, I'm just using a Raspberry Pi. And the interface between my target is Ethernet IP, as you see here. And here is my screen, my interface application screen, just for the, just a simple one. And this is the robot. Basically, is a robot pendant. Problem is that, not the problem, it's like I have no application running on the robot controller. It's just the background task of the option MX automation that is listening to the commands that are coming from the CodeSys program. For example, if for whatever reason the robot hard drive is damaged, let's say, and you need to replace it, okay? Replace the robot hard drive because you lost everything on the previous one. And you load the operating system, and after that, the MX automation option, the standard option on the robot controller, and because all the application program, the motion commands are coming from the CodeSys, the robot is ready to go. It's nothing that you need to do on the robot controller, just for the application layer. So you just, the robot will start listening, receiving commands from the same CodeSys, and it will do the same thing as before. So just, what I showed you in the slide here, this is live. I just changed something. That means the override. Override means the overall speed. Put it at whatever, 57%, and it moved here to 57. And for example, here is the tool number 1. But for whatever reason, I want to use tool number 2. That means it's the coordinates system with the tool number 2. And here, something. Maybe I put a restriction. I'll make sure that it is auto start. All right, started. So we can write, how much is the robot payload. That means the gripper on the robot. It weighs 1 kilogram, 5 kilograms, let's say 6 kilograms. It matters. It matters in general for the robot operation. And as you see here, the robot is in external mode. And on the robot side, on the pendant, we have the opportunity to put it, that means flexibility, put it in manual. If you switch the robot from the external mode, where it's listening commands from the CodeSys, the system will go into the stop mode. That means the robot cannot be in manual and receive external commands from CodeSys. It is against the safety regulations and is dangerous. And that's why we need to put the robot in external mode. And after that, we need to reset the old messages and to start. And all these indicators for the robot status will go green. That means everything is ready. The robot is ready to receive command. So for example, I want to move the robot, jog the robot. So problem is here we don't have a real robot. So I want just to display the actual position. So here we see 1477 on X, and here it should be the same thing. So I will, let's say, move the axis 1. Yeah, I just move it on the joint position, so I have to look at some other things. Come on, 11. So it is minus 11. So here it's moving axis 1. I move a little bit here. I just push, and it's going to a different value. Ooh, 0. I don't see it very well. It's 847. Here it's 848. Same thing. So whatever we do on the soft PLC into the CodeSys will be mirrored into the robot side. So this is a big advantage on using this option with CodeSys. That means from a single platform, we can program multiple robots. So from the same program, for example, that means the connection is done through Ethernet IP. If we would have 2 robots on the system, as I showed in the PowerPoint, from the same program, CodeSys program, I can send commands to both robots. We're going to have here 2 resources into the Ethernet IP, into the Ethernet connection. So from the same program, we can program the same CodeSys program. We can, let's say, send commands to multiple robots. So the big advantage is, it depends on the customers. So the maintenance and if they have already CodeSys and they know CodeSys and they use it already, they want to keep it, to use it for the all devices in the line. So basically, this was, what I wanted to show. That means from the PLC, from the CodeSys PLC, we can program the KUKA robot using the same unique system. And so this is, let's say, and we have robots, that means smaller, bigger, different sizes. And we can use, that means the same interface for a bigger robot, a smaller robot. And this is, let's say, the big advantage of that. Let's say, everything is kept in one spot on the CodeSys application program. So for the interface, we use, I just used Ethernet IP, but we can use different field buses. And we can use also UDP connection. But it's not very, let's say, used into the real manufacturing, the UDP connections. Maybe in some universities. And for the real production systems, Ethernet IP, Profinet, EtherCAT, this is how it's being used. So I think this is, what I wanted to show, the interface between the systems, the robot controller, and the CodeSys system using this option library. And of course, the end user can take advantage of all the flexibility of the CodeSys, the web servers, and monitoring, and all this online monitoring that can be done through the CodeSys system. It can also be done through the KUKA system, but let's say the advantage is, and the benefit is, to keep only one system. Many customers are saying, "Oh, we want a single system." So they have the choice. That means using KUKA system or the CodeSys system, but the majority, they like what they know the best. And I think this is I think we are a little bit ahead of time, and but this was what I wanted to show. That means the interface between this and the flexibility and between the systems. And if you create a program, for example, pick and place, or we have a customer that is using MX automation system for TIG welding. Why not? Because they use the PLC programming to manage all the TIG wave manipulation for welding, and they said, "Oh, why not? We're going to move the robot as well using the same system." So this is a way to keep to combine both systems. So I think, Michael, if you want to add something about in general, how the customers are perceiving are looking at this option, or if anybody, Chris, I just,
Yeah, so Constantine, thank you. Yeah, you hit the main point that many customers like the single source control that can be offered with the combination of the MX automation on the KUKA robot and the CodeSys software. It allows for single control, and it allows for uniform programming. So if they have techs that are based in PLC background, they can easily move into industrial robots. And this is very popular among plants that are moving into automation and have never had robotic applications before. It allows them to use their existing skill set of their employees to move into robotic applications. So that's the huge benefit, that the feedback from our customers. And that's also why we offer different field bus communications. In Europe, predominantly, you'll have the Profinet, Ethernet IP here in North America, and EtherCAT's up and coming, and it's one of the fastest growing field buses on the market right now. So having the ability to support the different communication protocols throughout the world, it makes this CodeSys control of a robot line a very efficient way for a company that's moving into automation that is truly a traditional hard automation PLC based background company. That's its biggest strength.